All right, team. So welcome to our seventh lesson for physics here. Again, we're going to kind of be continuing our lesson from Monday, talking about vectors. But this time we're going to be talking about how we graph vectors. And our need to graph vectors changes a little bit or it changes how we graph a little bit because now we have to deal with negatives, right? So before we get into specifically how we graph vectors, I do want to remind you of a few quick things about graphing, and then a few quick things about vectors, and then we'll hop into the actual graphing stuff. There's no actual notes to write here, and there's no examples to follow along with in your book. I want you to pay attention and listen and really make sure you understand the difference between graphing something that's got a negative velocity versus something that has a negative displacement or negative position. Okay, so before we get into anything crazy, let's talk about a few graphing reminders. Number one, when I look at a distance versus time graph, the y value tells us how far that object has gone. All right. Now I use the word distance here, and we know that distance is not a vector quantity, but I could replace this with displacement or position, and I want to do a better job explaining the difference between those two things today. Okay. Remember that the slope of a graph tells us the object's speed. And again, we can replace this word speed now with velocity, all right? It's the same thing, just one of them has a direction to it, all right? So what that means is I can actually now have a negative slope, all right, versus a positive slope, which is everything we saw last time. Okay? And remember that the shape of the line tells us the type of motion. For uniform motion, we're always looking for something that's got a straight line. These are beautiful straight lines. Okay? So here's my graph. With uniform motion, I know it's in uniform motion if it's a straight line heading like that. All right? That's everything we saw last time. If my line did something weird like curved or I don't know, went this way and then like turned and did that and had like a bend in it, then we know it's not in uniform motion. Okay, and those rules are all still true. Everything we talked about in regards to graphing is still correct. The y value still tells us how far it went. The slope still tells us the speed or the velocity, and the line's shape, the fact that it's a straight line, still tells us that it's in uniform motion. But now that we have vectors and we have negative numbers, it's going to start messing things up a little bit. But all these rules still hold true, so I want you to remember this the entire time that we're working through this today. Okay, so some more reminders for you, this time talking about vectors. So again, this is stuff that we brought up from Monday, but more of the theoretical piece to it. I'm not so stressed about the numbers today. I care more that you understand what these things mean. So a few of the things about vectors before we get into graphing is number one, whether a number in a vector measurement is positive or negative, all that does is tell me which direction it is or which direction it's moving in, okay? The positive or the negative just tells me a direction. For today's notes, I'm going to use left and right consistently, just because I like those two terms just for this, but I could replace that with north and south, east and west, up and down, but I like left and right. I find it a little bit easier to kind of talk about, okay? Now, remember that if I have a positive or negative displacement or position, that tells me where an object is located. And I want to hone in on these two terms a little bit more before we get going, right? So displacement was mostly what we talked about on Monday. Basically, how far is an object from where it started, right? So if here's my starting point here, okay, and let me just quickly draw a circle in here. Okay, so if this is my object here, and it starts on that starting point and goes all the way over here and then walks backwards and stops here, the displacement is going to be this distance, how far it is now from where it started. Position is a similar thing. The difference is the starting spot. Whenever I talk about position, what I'm talking about is where something is located in terms of some reference point. In other words, really the difference between this and this is it doesn't matter where this thing started. What I care about is how far is it from a reference point, from me, from where I'm standing, from its house, whatever it happens to be. So in the first case, the object had to start here, walk all the way over here, and then come back to here. In the second case, when we talk about position, all I'm asking is how far is this object now from this reference point, from this spot? What is its position compared to it? Okay, so it doesn't have to have, the only real difference is it doesn't have to have started there. That's really it. And when we graph vectors, we talk typically about position versus displacement. because the object does not necessarily need to start at 0. It doesn't need to start with 0 displacement. Okay, so I just want to make sure you guys have a better idea of those terms. And so if I have a positive position, it means I am located to the right of my reference point. If I have a negative position, it means I'm located to the left of my reference point. That's all it means. It's where am I compared to some reference point. Positive just means over here, negative means over here. It could be anywhere in here and still have negative displacement. It could be anywhere over here and still have positive displacement. All right? I like this circle. I'm going to keep using it. All right. So then positive and negative velocity, really all that's telling me is which direction is that object moving compared to my reference point. All right. So when I have a positive or negative velocity, it is just which way is the object moving. Is it moving to the right or is it moving to the left? Okay. So if my object is going this way to the right, it's got positive velocity. If it's heading this way, it's got negative velocity. And so what I'm going to quickly do is just draw another reference point here right in the middle, because this is something that I find students get a little bit mixed up on. All right. This object right now has negative displacement because it is or negative position, I should say, because it is to the left of my reference point. It's over on this side. Okay. This object, as I move it around, right now, it has negative velocity because it's moving to the left. So as it's going this way, it has negative velocity and negative position, right? Because it is to the left of the reference point, so at negative position, and moving left, so it has negative velocity. When it's over here, and we move it this way, right now it has positive velocity because it's moving to the right, and it has positive position because it's located to the right. Okay? Here's where things get weird. I can have an object with negative position, but positive velocity. Okay? Remember that velocity just tells us what direction it's moving. Position tells us where it is. So, to show you this, here's my object. It currently has negative position because it is to the left of the reference point. If that object starts moving to the right, starts moving this way, it now has positive velocity because it's moving right. All right, so negative position, positive velocity. Okay, I can do the same thing on this side. I can have positive position, but negative velocity. All right, let me just quickly erase this guy here. Okay, I can have negative velocity if that object is located to the right, but is moving left. There we go, like that. Okay, so again, positive position because it's located to the right, negative velocity because it's heading left. If this object kept going, right now it's got positive position, negative velocity. If it keeps going, hits the reference point, right now its position is 0, but its velocity, because it was moving, is still negative. And if it kept going, now it has negative position and negative velocity. I can do the same thing the other way. Right now, negative position, positive velocity, positive velocity, positive velocity. Still positive velocity, but 0 position. Now positive velocity and positive position. Okay, so I want you to understand that position and velocity are related, but they are two different concepts. Position tells us where it is, whether it's located on this side or on this side. Velocity tells us, is it moving this way or is it moving this way? Okay. Okay, so let's take a look at our first graph with vectors on it. All right, and technically all the ones that we did last week could be vectors as well. They were just things that had a positive position and a positive velocity. Okay, but this graph looks a lot different than the ones we saw last week. Still got, you'll notice a few changes. One, instead of distance, I'm using the word position. Okay, that's important because position can be negative, distance cannot be negative. Distance doesn't have direction. Okay, so that's my first major difference. The other major difference that I hope stood out to you right away is that this line is going down. All right, every single graph that we looked at last week did something like this, or like this, or like this, but they all went upwards and in straight lines. Okay, that upwards being the key. Vectors, because they can be negative, can go down. All right, So what I want to do is just quickly do a slope calculation for this graph here to show you kind of what happens. And because I didn't use a ruler, my scale here got a bit weird, which is why this dot doesn't fit on the line, but don't stress about that. Let's pretend it does. So let's just do a quick calculation here. I want to find the slope of this line. Our slope calculation does not change. The slope is always that y2 minus y1 over x2 minus x1. Okay? The difference here is we can get a negative number. Okay, so I'm going to pick 2 points on this graph. I'm going to pick this point here and this point here, but it really doesn't matter. This is going to be x1, y1. Okay, and I know that because it is the one that's got the smallest x value. This guy over here is going to be x2, y2. Okay, and again, we know that because it's got the bigger x value. I don't care that it's small or further down on the y-axis. I only care about the x-axis. So now we're just going to come up with our coordinates. This one here is technically 130. This one over here is 310. Okay, so now we're going to take our numbers. We're going to plug them into our equation. I'm just going to give myself a little bit more space here. Okay, so we're just going to get rid of some of this. All right, so I'm going to plug my numbers in. I'm going to go my y2, which is 10, minus my y1, which was 30, divided by my x2, which is 3, minus my x1, which is 1. When I do that, I get negative 20 divided by 2. Okay, when I do that division, I get negative 10, and my unit here is still going to be meters per second. My slope still tells me the speed, or the velocity I should say in this case, and the big difference between this calculation and the ones we did last week is right up here. Up here, every one we did last week was always the bigger number minus the smaller number. That's no longer the case. Okay, so when I do my division, I have to keep that negative 20, then that gets me a speed of negative 10 meters per second. All this means is this object is moving 10 meters per second, and I'm going to say to the left. Okay, and I don't have space to write out the word, normally you would. All right, so that's all that's saying. When I have a line going down, that's showing me that the object is moving in the negative direction. So because today we're going to use right and left the whole time, this just means that this object is moving to the left. Okay, whereas if I did the slope for a line like this, it's heading to the right. Right? So whenever you see a line going upwards, that's an object moving in the positive direction. Whenever you see a line sloping downwards, that's the object moving in the negative direction. That's the only difference between these two things. All right? Okay, now we're really going to mess you up. So when we do graphs with vectors, a lot of the time our graph ends up actually looking like this, okay? Where I have my x-axis in the middle, okay, and that's my 0 position. That is my reference point. So you can think of this line here, this 0, as the reference point that we're comparing it to, that little green dot that I was moving that circle around a couple of slides ago, all right? Because our position can get negative, all right, that's again just telling us where the object is located, okay? So we can have a negative position, so we need to have this 0 in the middle so that our line can either go up or down or cross the line or come from here up or from here down. Basically, we need to be able to work with negative positions, right? And so we set up our axes to look like this here. We never are going to have time going this way because I can't have negative time, but I can have negative position, so I want to have something like that. And mostly what I care about today is I'm not going to do a ton of slope calculations. That last one we did was the only one. I care more that you understand how the shape of the graph tells you what's happening, tells you the story of how that object is moving. You just need to know what to look for. So I'm going to do 4 examples with you guys on really what the 4 types of vector graphs can look like. So the first one we're going to do is an object moving away from our reference point to the right. Okay, in other words, this thing is getting further and further to the right of our reference, right? So number one, I want you to think about the idea of the fact that it's moving away from the reference. If it's moving away from the reference, what that means is its position is getting further and further from the reference. In other words, my line should move away from this 0. I should end up either up here or down here, depending on what direction this object is moving. All right, and it's moving away from the reference point to the right. That's telling me it's moving in a positive direction, meaning that it has positive velocity. Okay, Positive velocity means my line should go upwards like this. It is moving to the right. It has a positive velocity. Okay? And it says it's moving away from the reference. That implies that it's starting at the reference. I probably should have been clearer on that, but let's just assume that we are going to do that today. So to draw this graph, basically we're going to start at our reference, and it's moving away to the right, meaning it's going to have a positive slope. So all I'm going to do is this. Okay? You can tell that this is the correct graph for this particular scenario because the object is moving, starting at the reference, to the right. You'll notice it has a positive position because it's above the line. So it's moving to the right, so it's to the right of the reference. And it has a positive slope. That means it's got a positive velocity, so it is moving right. Now this looks just like all the graphs we did for uniform motion last week where they were the distance time graphs, and that's because this thing has positive velocity. It has positive position, and it's not changing directions at all, so it is going to look like that. It's going to look exactly like that. Let's start talking now when we start having negatives come into this. Okay, so this is going to be a similar scenario. We have an object that is moving away from the reference point, so assuming, and I really should have put it in here, but that means it assumes that it starts at the reference. Okay? And this one is going to move away from the reference to the left. Again, because it's moving away, it means it's going to get further and further from zero. It's either going to do it this way or this way. All right? So what that means is I should either end up up here or down here. Okay? But this time this object is moving to the left. That's a negative direction. Okay? So what that means is if this thing is starting at the reference and moving to the left, its line is going to look like this. Okay? Now that should be a straight line, but I can't draw very well. And the idea here is this object is getting further and further away, but more and more left. So it's going to end up down here because this is the most left it could be. Let's say that's negative 10 meters away. Okay? This object, you'll notice, has a line going downwards because it has a negative slope. It has a negative velocity. So it is moving left, so it must be a downwards slope. Okay? So which direction it's moving tells you whether the line should be going upwards or downwards. So these ones, the last two examples are both cases where the object started at the reference point and moved in one direction or the other. Let's talk about some other scenarios that we can have that look more like the graph that we calculated the slope on a few slides ago. All right, so this one, the wording is a lot different. Okay, it's got a few key things, and I made them all bold here just so you could see them. This time we have an object that is moving towards the reference point. Okay, so it means it's going to get closer and closer to zero over time. It's either going to come this way or it's going to come this way. Okay, but at the end, if it's getting closer and closer to reference, it's going to get closer and closer to zero. Okay, and the object is moving from the right. Okay, if it's starting at the right, which means it's starting up here and moving closer and closer to zero, that means the line has to come downwards like that. What that means is it's going to have negative velocity, which makes sense, okay? If it's starting to the right and it's getting closer and closer to me, that means it's moving left, okay? If I quickly get my circle up here again, okay, and I have my reference point over here, okay, all this is one of those cases where the object is starting over here and is moving closer and closer to my reference point. It is moving left, so it has a negative velocity, okay? So I'm just going to quickly get these guys out of the way. Whoa, there we go. And so we're going to draw this line. So this object is starting from the right. Okay, it's got a right position up here, and it's going to get closer and closer to zero over time. Okay, this looks like the graph that we calculated the slope on 2 slides ago. Right, this object has a negative velocity, and I can tell that because the slope is down. All right. And it is got a positive position, and I can tell it's got a positive position because it is above my x-axis. It's up in here rather than down in here. One more example like this, and then we'll talk about speed time graphs. Okay, last example, the only one we haven't done. Again, very similar wording to the last one. This one time we have an object moving towards the reference, but this time it's coming from the left, meaning it starts with a very negative, very left position down here, and is going to get closer and closer to zero over time. Okay, so I just use my laser pointer for that. Let's just draw the line though. This is basically what we're going to draw. All right, this thing started out with a very left position and ended up closer and closer to zero. So this thing has a positive velocity, and we can tell that because the line is sloped upwards, but it has a negative position, and we can tell that because the line is below our x-axis, all right? So those are the four kind of velocity time graphs, or sorry, I should say, not velocity, the other one, position time graphs that we can draw, but we can figure out which way the object is heading by looking at the slope of the line. Positive slope means positive, or means it's moving in the right direction. Negative slope means it's moving in the left direction. Okay, and we can tell where it's located. Above the x-axis means it's located to the right of my reference point. Below the x-axis means it's located to the left of my reference point. So those are the two little bits of information you can pull off the graph. We didn't need any numbers to do that. We just had to look at the shape of the line, and that's the more important part today. So I just want to take a quick second. I won't go as long and detailed in this one, but I want to draw all of those graphs all together. Okay, so the first one, we said we had an object that started at the reference point and moved to the right. Okay, got a positive slope because it's moving to the right. Right, it's getting further from the position or the reference point, and it has a positive position because it's above the x-axis. The second one, we said we have an object that is located at the reference point, moving away to the left. Okay, so my object gets further and further from my reference point. It's heading in the negative direction because it's got a negative slope, and it has a negative position because it's below this line. Right, so you guys are just kind of mirror opposites of each other. Third example we said we had an object that is starting to the right of our reference point and moving towards it. Okay, notice that this guy has a negative velocity because it's sloped downwards, but a positive position. It's above my x-axis. And then our final example we said we have an object starting to the left, moving to the right, moving towards our reference point. It's going to look like that. A couple of things I want you to notice here. Both the green lines have positive slopes. They are both moving to the right. Okay? In this case, we're getting further from zero. This case, we're getting closer to zero. Doesn't matter, but they're both moving right. The difference between this green line and this green line is this one has a positive position, this one has a negative position. Beyond that, they are not any different. The shape of the line is the same. Same thing with my two red lines. This one here is moving away from my reference point. This one's moving towards it. This one has a negative velocity. This one has a negative velocity. All right? They're both moving left. This one just happens to be getting closer to me. This one happens to be getting further from me. This one here and this one here, the only difference between them is that this one has a positive position. It's located to the right. This one has a negative position. It's located to the left. And we can tell that because this one's below the line, the x-axis, I should say. This one's above the x-axis. You could have a case where, let's do my green one here. When I look at this third line down here, or the fourth line we drew, this guy here, this green one, if it kept going past the reference, it's going to do this. Okay? Basically, the story here is that I have an object moving closer and closer to my position, my reference point, and then it hits the reference point and then keeps moving past it. But it has a positive velocity the entire time. Its position is becoming more and more and more to the right as time goes on. All right, so I want to show you a different type of graph now where we have changes of direction, because everything that we had on those previous examples, everything was going in the same direction the whole time. All right, so this one says we have a man that walks up 6 flights of stairs, stays on the floor for a while, then goes down 3 flights of stairs where he then remains. A couple things I want you to notice about this. I said today I don't really care that much about numbers. It's because I don't. I care more about that you guys can come up with the shape of the graph. I care more that you understand the vectors part of it, like when the line is moving up, when it's staying flat, and when it's moving down. All right. So in this case here, I'm not going to use any numbers. I don't care if you were to do this example, and it's not in your book, but if you were to do this example, you might have a slightly different graph than me, but they should have roughly the same shape. Okay. So if this man is going up 6 flights of stairs, that's positive, right? Up is a positive direction. So he's going to go up 6 flights of stairs. I don't have any numbers down here for time because I don't really care about the numbers. I didn't have 6 up here. I could have, but I don't. Okay? Because it doesn't matter. That man stays on that floor for a while. Remember, when somebody's not moving, their line is flat. Okay? So he stays on the 6th floor for a while, and then eventually he heads down 3 flights of steps. So I want to go about halfway down. Okay? Goes down 3 flights of steps, and then he stays there for the rest of the time. Do you see how this graph tells the story that I've written here? I have a man going upwards, positive direction, staying there, staying flat, and then heading downwards, going in the negative direction. Positive velocity, negative velocity, 0 velocity. He then stays there, so another 0 velocity. Okay? This story here, or this graph, does depict what's happening. This is not uniform motion, which is okay, right? If I gave you a graph like this and I asked you if it's in uniform motion, it's obviously not. But from here to here, he was. From here to here, he was in uniform motion. Here to here, he was in uniform motion. Here to here, he was in uniform motion. But the entire trip is not in uniform motion. Last little thing that I want to talk about, I don't want to spend too much time on it because it's a lot simpler, is the idea of a velocity time graph. Right? Remember that if something's in uniform motion, just like on a speed time graph, it will always make a flat line like that. That's really flat. Let me try that again because that's going to bug me. So we want to have a flat line like that one there. Okay? This is an object that is traveling with a uniform velocity. Okay? But I can also now have a velocity like this guy down here. Oh, I don't want to do that. I want to do it a little bit different. Oh no. Sorry. There we go. Okay, I now have another object down here, which also has a velocity. It's also in uniform motion because it's a flat line, but this one has a negative velocity. Okay, that's all. The only difference here is that this object up here is moving to the right. This object down here is moving to the left. I have no idea what their positions are, and I don't care to know what their positions are. It does not matter to me. I can't get that information off of this graph. All right? But if this object is moving to the left, we can tell that because it's down below my x-axis. Here the velocity is positive, so it's moving to the right. But the other type of question I could ask you is which of these two objects is moving fastest? And the way we can tell that is how far they are from my x-axis. Okay? Before, when we did the speed time graphs, I said, oh, whichever line is higher up, that's the one that's moving faster. That's no longer the case. It's more about the absolute value now, or basically just how far is it from the x-axis. My blue line is way further from my x-axis than this one is, which means that this one is going faster than this one. It's just going to the left instead of to the right. All right? So if I threw some numbers on here, this might be, negative 10 meters per second. This might be positive 5 meters per second. The positive negative just tells me the direction. What I care about in terms of how fast it's going is the number that's there. So that's going to wrap up the lesson for today. Again, not a ton of math today, which is nice. In fact, none of the practice stuff that you have to do has any math in it. What I care about today, as I said, is that you understand the shape of the graph. Okay? So what I'd like you guys to do, there's questions on page 12 and 13, kind of like that man going up and down the stairs practice that we just did. Where it gives you a scenario and it wants you to draw the shape of the graph. Don't worry about putting numbers on your graph at all. If that helps you, then do it, but don't worry about it because it's not giving you any numbers in the questions. Your shape may end up looking different than your friend's shape or than the shape that I drew in my answer key. Don't worry about that either. As long as your shape is close to mine or similar to mine in some ways, that's all I'm looking for. The idea that you understand when something is moving with a positive direction versus a negative. I will say the second question about the dog running around on a chain is really, really tough. If you get an answer and then you go and look at mine, you're going to be probably confused. I'll go through that question in our virtual class on Thursday. All right. But that's it for me for the week. I hope you guys have a great week. I will see you guys in virtual class Thursday. And remember, we are going to have a quiz next week. I'll talk more about that though. All right. Hope you guys have a great day. We will see you later.